Chapter 1, Trigonometry, Section 1.1, Angle. Now, angle, what is an angle? So we start in Arabic, angle is zawiya, zawiya. So we start with defining a line. A line is straight path connecting two points A, B, and extending beyond the points in both directions. And here, how we show a line is this. It's missing the arrow here. So this is the official, notation for it. And the portion of the line between 2 points, including the points, is called the line segment. And here is the line segment, and here is how we denote this. Show it. You see, then there's an overline. There's a line over AB, and array is the portion of the line that starts at one point A and extended to infinity beyond B. And A is called the endpoint of the ray. So array is this one here. It starts from A and it passes through B, and it moves forward after B. So here we use this notation here. And ray in Arabic, ray, I think shu'a. I think it's shu'a, something like this. Okay, an angle zawiya, as I said before, consists of two rays with a common endpoint. So this is the case here. The angle is, in some book it says that it's the union of two rays with a common vertex. So it makes these two rays make an angle. And these two rays are called the sides of the angle. So these are the sides here. We call it this one here, initial side, and this is terminal side. And this initial and terminal side depends on, how you form the angle. So the clockwise direction or counterclockwise direction, this will be important. But anyway, we'll see it later. The common endpoint of the two rays is called the vertex of the angle. So B is the vertex here, and the notations are this one here. So this one here is ABC with a hat, let's say, and a triangular hat. And this one is another notation for it. Now ABC means A, B, C. So the middle term here comes to the vertex here. So it says B is the vertex here. Or sometimes we use the angle B, or we use this one here, the hat. A triangular hat is also used, or we say angle ABC or angle B. So these are different notations you might see in the books about angles. Now I said there's an initial side, there's a terminal side, and it depends on how you make the angle. So if you form the angle this way, like take the initial side, then make the angle this way, so it's terminal side. Or if you take the initial side and make the terminal side this way, so it will be negative angle and positive angle. Okay, so you might ask this question here. What is this here? So this is positive or negative. Okay, guys, positive angles, we will take them all positive, okay? But negative angle issue, this positive angle and negative angle and clockwise issue will be used, okay? Will be used when we place the angle in the Cartesian coordinate system. So, we will talk about, this here. There will be the angle here. So if you put the other terminal side, so if you look at here this way, it will be minus some angle. But if it goes this way, you will say it's plus something. So it will be a minus angle here, and this will be a minus angle. So it will be important in here. Okay, for now, it's not a big deal. So if we give you an angle, it's just positive angle. So the negative angle or the counterclockwise, the clockwise direction issue will be important when we deal with the angle in the Cartesian coordinate system. So, but it's better you know them, like this negative, we form it by doing this, and we form the positive angle by doing this. So counterclockwise direction, clockwise direction. Now, how can we measure an angle? So there are different measures of angles, but here we will learn the degree measure of angle. So we will call, okay, one complete turn is equal to 360 degrees. So we will call it 60 degrees, 360 degrees. And it's, yeah, one complete counterclockwise rotation will correspond to 360 degrees. So then we can ask this question, so how, what is the measure of this angle then? So what about the quarter here? The quarter will be, of course, 90 degrees. And what about the half half turn? So it will be 180. So we are trying to rate it according to 360. So as you see, it's one complete revolution, we say 360. So then by using this, we prorated. 360 means like one complete turn. Half rotation is 180, and then a quarter rotation is 90 degrees. And here is the classification angles with respect to their measures. This angle here, 180, is called straight angle, and this corresponds to a half rotation. And now this is 90 degrees, and it corresponds to a quarter rotation, and we call it right triangle. So this is important here. You have to know what is right angle. Right angle. So it means 90 degrees. So this is important. It's the most important angle type you have to know. And then we have the acute angle. So acute angle is an angle whose measure is between 0 and 90 degrees. So we call it acute angle. So this is also an important one. And we have an angle whose measure is less than 180 and bigger than 90 degrees. It's called obtuse angle. So obtuse angle. So we learned, okay, this obtuse angle is important, of course. You have to know, but it will not be used as much as right angle. So it will be, you'll hear a lot, right angle, acute angle, and a straight angle, then an obtuse angle. So these are, I can give them 2 stars or 3 stars maybe, but right angle and acute angle are definitely 4 stars or 5 stars. Now let's do the classification. Determine the type of the following angles according to their measures. It's 40 degrees is as you know, it's less than 90 degrees, so it's bigger than 0. So we say it is acute angle, and here it is between 180 degrees and 90 degrees, and it becomes, okay, phi or phi is an obtuse angle. And then here, 180 degrees is making a straight angle. Straight angle. So this is sigma is, because we say sigma is a straight angle. Now we can classify the pairs of angles. Now, if the sum of the measures of two positive angles, alpha and beta, is 90 degrees, then these angles are called complementary angles. And we say alpha is the complement of beta, and vice versa. What here mean by vice versa is means beta is the complement of alpha. So you can say that, and you can say that. So it's, yeah, complementary angles means their sum will be equal to 90 degrees. So as you see, this alpha beta, their sum is equal to 90 degrees. Sorry, this is alpha beta, 90 degrees. So they are complement of each other. Now we have another type of pairs here, pairs of angles. If the sum of the measures of two positive angles, alpha and beta, is 180 degrees, so it means here alpha plus beta is equal to 180, then the angles are called supplementary angles. And so as you see here, they will make a straight angle, and their sum is equal to 180 degrees, and we call this alpha is the supplement of beta, or we can say beta is the supplement of alpha. Now let's do some examples. Find the complement of 50. So remember that the complement, so when you say complement, means like the angle completing the other angle to 90 degrees. So it's 90 minus theta, or 90 minus 50, it will be 40 degrees. And what's the supplement of 180? Supplement means it's completing the angle to 180. So complement completes the angle to 90 degrees. Okay. So this here supplement, we say it completes the angle to 180 degrees. So what completes this 110 to 180? So it will be 70 degrees. Okay, let's look at this problem here. An acute angle's measure is twice its complement. Find the measure of this angle. So an acute angle, so here it's telling us an information about an acute angle. So we have an acute angle and its measure is twice its complement. How can we set up this relation? So in this question, it's better we go from the unknown variable. So we call this acute angle x. So let's say x, and its measure is twice. Twice means, okay, it means equal to, twice means two times, so it's complement. So the acute angle is, let's say the acute angle is x. So what can you say about its complement? Okay, first let's set up these two, then we will set up the equation. Its complement. So if the acute angle is x, what is its complement? So its complement will complete it to 90, so it will be 90 minus x. So I want to show you this x plus 90 minus x. It's 90, you see? It's x, the acute angle, here its complement. Okay, now let's use this information. And acute angles measure x, so which is x, call it, and then equal to, its measure is equal to is twice its complement. Complement means 90 minus x. So then we'll find the x value. Now we can, solve this equation. So we would get x equal to 2 times 100, 2 times 90, which is 180 minus 2x. So it will be 3x is equal to 180 degrees, and x will turn out to be 60 degrees. So this is the solution here. So here in this type of questions, it's better first you name the angle as x, because we don't know it and we want to find it. So then set up its complement in terms of x. So write it in terms of x. So if the acute angle is x, then its complement is 90 minus x, because their sum will make 90 degrees. And now we use the information to set up the equation, and we solve for x and we find it. Okay, then you have the slide here, the slides in the blackboard, you can find it. And here you can see its solution is written also. Now, an angle's measure is 30 degrees more than its supplement. So it says an angle's measure is 30 degrees more than its supplement. Find the measure of this angle and determine whether it's obtuse or acute. Now, we have an angle, so this angle's measure is 30 more than its supplement. So this is the key information we have to use. And it says find the measure of this angle. Okay, let's first find this measure of this angle, then determine whether it's obtuse or acute. So the angle's measure, you can start by saying let our angle is equal to x. Then we will use its supplement. So what is its supplement? Then its supplement is what? So if the angle is x, then its supplement will be the angle which completes x to 180. So it has to be 180 minus x. You can say x plus the angle its supplement will be equal to 180. So you can say, you can send x to the other side. It will be supplement will be 180 minus x. This is how you can think here. Now then we use this, we set up the equation by using this information. The angle's measure, which is x, is 30 more than, okay, 30 more than, it's important we write here plus 30. Then what? Its supplement. What is this? 180 minus x. So these are all in degrees. So it will be, if you solve this one, you will get x equal to 210 degrees. So it will give us x equal to 105 degrees. Now, x is 105 degrees. So the next thing you have to answer is, is it obtuse or acute? Because it's saying determine whether it is obtuse or acute. So we say it's less than 180 and bigger than 90 degrees. So it will be obtuse. Okay, I'm sorry for this, it's a little small here. But anyway, you will see the explanation here in the slide. We typed it, so it looks better than mine. Okay, let's look. Now here, x, then its supplement will be 180 minus x. Then we use this information and we set up the equation, and we find it. Then we say, hey, it's more than 90 and less than 180. So it's the angle is obtuse. Okay, now let's do this triangle exercise. It says, assume that the measure of an angle's supplement is 30 degrees more than twice the measure of its complement. Find the measure of this angle. Okay, please stop the video and try to do it by yourself. Then you can start the video and see my solution. Now here, Yeah, the measure of the angle, it says the measure of an angle supplement. Okay, let's say the angle we are looking for is the angle, the angle is x, let's say. So this is the angle we are looking for. And it says the measure of an angle supplement. Okay, so it's the angle supplement. What is the angle supplement? It will be 180 minus x, it completes it to 180. And here we say is 30, okay, more than twice the measure of its complement. So before writing the equation, I'm trying to write everything I need in terms of x. So the measure of its complement is the angle's complement. Now, what is the angle's complement? It's 90 minus x, because when you add them, it will make equal to 90. Anyway, now we have these three of them, and we will use them in this. We will use them in setting up the equation. Let's use this in the measure of the angle supplement, which is 180 minus x, equal to is 30 more than twice 2 times what? The measure of its complement. Complement is what? 90 minus x. Okay, then the next thing is you have to solve the equation for x, and it will be 180 minus x equal to 180 minus 2x plus 30, and then 180, okay, they cancel out, and it will be x is equal to 30 degrees. So the angle turns out to be 30 degrees. And you can check it again here, like 30, put 30 here, and put 30 here, and you can see. So its supplement is 180 degrees, and it is 30 more than twice its complement. Complement is 90 minus 30, so it makes 60. So you can check the equality holds, the equation holds. Now we will try to measure the angle by using radians here. So in radian, we use a unit circle. Now look at here, assume we put the angle here as a central angle. So central angle is here, we put our angle to a circle. Inside a circle at the center, we put the vertex at the center. And now this angle here, we want to measure this angle in terms of the arc length here. So if r is equal to 1 unit, so we find the length of this arc as theta unit, and we say if it is theta units, it's theta radians. So basically, the key idea here is in this type of measure, so you find the arc here, the arc length. So let's say arc length is 5. This is 1. Then you say, then this theta is 5 radians. So the important thing is the arc length here. If the arc length subtended, okay, the arc length is 5 for this central angle theta, and the radius is 1, then we say theta is 5 radians. So basically, if radius is 1 and the arc length is 5, then theta is automatically 5 radians. Now we can, okay, what about this here? So if it is, let's say, 1, and this is, let's say, uh, pi over 4. So assume we calculated the arc length is pi over 4. And what is theta? Theta is in radians. It's pi over 4 radians. So, but the whole circle will be equal to how many radians? So let's look at this one here. So, okay, now let's look at here the circle here. 1, radius is 1. Then we are looking at this angle here, theta. So theta is how many radians? Now, this whole arc here, the whole arc, it means like the muhit now, the perimeter of the circle. So this here is this arc, I mean the whole circle, circumference is 2 pi times 1. This is coming from the circumference of a perimeter or muhit of a circle is equal to 2 pi r, you know. The perimeter or the circumference of a circle is 2 pi r. If you don't remember, okay, I'm using this one here. So r is equal to 1, then this will make 2 pi. And now this theta will be at most what's the length of this, what's the circumference? It's 2 pi, so it will be 2 pi radians. So indeed 2 pi radians means in terms of degrees it will be 360 degrees. So this is the key idea here. So we want to look at the arc length, corresponding arc length to that angle, and here when r is equal to 1. So it's 2 pi radians will be equal to the whole angle here, one turn. So it will be 360. Now here, okay, I want to show you this one. Central angle is an angle that has the vertex at the center. See here, this is the central angle. And the amount of the rotation of central angle is associated with the length of the arc by which the angle is subtended. So this is the arc here, and this is the angle here. This is central angle. Now we are trying to measure the arc length. So when we measure this one, we will say it's equal to the same number here. So one complete turn equals to the circumference of the unit circle, which is 2 pi, and we will use the word radian for the unit of such measure of angle. So one complete counterclockwise rotation is 2 pi radians, as I said, so it will be like this. So when you calculate the muhit here, it will be 2 pi. So then you say one complete turn is equal to 2 pi radians. So now let's try to understand this. Okay, so let's look at this example. Find the measure of the central angle theta inside the unit circle. This is the central angle is here and inside the unit circle. And by using the length of the arc by which theta is subtended, here this is, okay, we want to find this angle theta by using the arc length. So the only thing you have to pay attention to here is r should be equal to 1. So r is equal to 1, it's given here. Then theta is automatically what? Theta is equal to the length of the arc. So theta is automatically pi over 3. Because theta is equal to the length of the arc. Okay, it's this when r is equal to 1. Now let's try to do this one. Find the measure of the central angle inside the circle that is subtended by an arc whose length is 1/3 of its perimeter. So let's try to understand this. Find the measure of the central angle inside the unit circle. So the unit circle is this one. And now there's a central angle. Central angle means located at the center. It's this. Now let's say this is theta, let's say. And that is subtended by an arc. So now it sees its corresponding مقابل. Its corresponding arc is here. So in English we say subtended by an arc. So theta is subtended by an arc here, whose length is 2 pi of its perimeter. So 1/3 of its perimeter means, okay, perimeter means here of circle. What is the perimeter of the circle here? So it means this one. So this is equal to 2 pi times 1. This is 1 here, right? Unit circle. So 2 pi times 1. So the arc length, it says the arc length whose length is 1/3 of its perimeter. So arc length is 1/3 of perimeter. So how do you find it? So the 1/3 of 2 pi is, how do you find the 1/3? So you multiply 1 over 3 with 2 pi, so it will be 2 pi over 3. Now then, what's the arc length? Arc length is 2 pi over 3. Now what can you say about theta then? So in this case, you say theta is also equal to 2 pi over 3 radians because of the arc length. Now we are trying to, okay, we will try to convert the radian to degree and degree to radian. So okay, we start from always the one turn in degrees is 360 degrees, and one turn in pi radians is 2 pi. Now by using this, like, you can rate them, divide by 2, so you got pi radians equal to 180. So you can find these find this conversion formulas. Basically, okay, you can calculate them. I mean, you can use them. 1 radian is equal to 180 degrees, or x radian is equal to 180 x over pi degrees. This is what I do basically. I write pi radian is equal to 180 degrees. So if I want to find, for example, let's say 120 degrees, so I write here the x, then I multiply them. So I got x times 180 is equal to 120 times pi, and then divide by 180. So then we have this one. Or, okay, assume here it's given like that. For example, 2 pi radian is what? So you can write here x. Then you can use this multiplication. 2 pi times 180 is equal to pi times x, and divide by pi, and then you will end up with 360. So you can use the proportion here if you want, but here this x I use here and this x here, no, they're not the same. Okay, they're not the same. So if you want to use this formula, you say x degree here, you want to use this 120 degree is how many radians. So if you want to use this one, we'll put here pi times 120 degree divided by 180 radians. So it will be radians. So when you do it, it will be 2 pi over 3 radians. So you can use this one. And in the other way, so if radian, okay, if the degree is given, no, the radian is given and it's asking the degree. So for example, assume we have let's say 3 radians. Okay, how much degrees or how many degrees? It's asking this, so you can say 3 radian is equal to, you can use this formula here, so it will be 180 times 3 over pi, so the 540 over pi degrees. We can use this one. let's do this example. Write 75 degrees in radians. Now, you can use several ways to answer this question. One way is 75. One way is to use this equality here. Pi radians is equal to 180 degrees. So 75 degrees is how many radians? So you can multiply them, but 180 x is equal to 75 times pi divided by 180. So x is equal to, well, after the simplification, you will get a 5 over 12 pi. I mean, you can try to do it. This will be pi over 12, 5 pi over 12. So you can do this way. Or another way is, if you don't like it, you can use the formulas given in the previous slide. So you can say 75 degrees is equal to 75 times pi over 100. So you can use this formula here. Now, let's do the other way. So it says write this one in degrees and determine whether it is obtuse or acute. So if you want to go with the pi radians equal to 180 degrees, you can use this one. Pi over 5 radian is equal to how many degrees? So you can set up a direct proportion, and then so it will give you 2 pi over 5 times 180 is equal to x times pi, and then it will be 2 times 180 divided by 5, so it will be something like 72 pi. You can do some calculations here, I mean simplifications. Divide by pi, so you will end up with x equal to 72 degrees. Okay, that's one way to do it, and this is an acute angle for sure. And the other way is you can directly use the formula of 2 pi over 5 radian. Is okay, this is how you do this. Pi radian is always 180 degrees, so you can say it's pi over 2 times 180 degrees. So you replace pi radian with this 180, so you got 72 degrees, and 72 degrees is an acute angle. Okay, let's see how it is solved in the slide. Now let's, okay, it says convert degrees to radians and vice versa, and write 30 degrees, 45 to 90, and 180, and 360 in radians. So basically, okay, you can start from the base here. The pi radian is equal to 180 degrees, and you can directly say, okay, it's automatically pi radian. Now, if you want to get the double, so you will have a double radian here, 2 pi radian. So this is, I think, easy to figure out. And now, if you want to have the 90 here, so you can say your x, and then you multiply 180 times x is equal to 90 pi, and divide, no, sorry. No. We want to find x, so we have to divide 90 by 180. So it will be 1 over 2, so it will be pi over 2. Now, let's do the others. Okay, I'm using this pi radian is equal to 180 as the base equality. So I'm trying to do everything from here. Okay, let's say 45 degrees, and then let's say x, and you multiply these two and these two. You got 180, x is equal to 45 times pi, and then divide by 180. You want to make x alone here, isolate. So then you will get pi over 4. Now, in the same way, you can do the rest. So it will be here. It will be 2 pi over 4. No, pi over 2. Sorry. And this is pi over 4, and then this will be pi over 6. And let's look at here 1 radian, 2 radian, pi over 3 radian, and 3 pi radian, and 2 pi over 3 radian in degrees. So again, I will use the same thing. Pi radian is equal to 180 degrees. So 1 radian is how many degrees? So you just make x. You do the same thing. You cross multiply them. You get x times pi is equal to 180 times 1. So x is equal to 180 divided by pi. Okay, it's this one. 180 divided by pi degrees. And okay, we do the same thing for 2 radian. So since it's twice the first one, it will be 360 divided by pi. Now, how about, pi over 3 radian? So pi over 3 radian will be equal to what? So x, we multiply pi times x equal to 180 times pi over 3. And you can divide both sides with pi. Pi cancel out, and x equal to 60 degrees. And you can do the rest the same way. It will be equal to this. You can calculate. You will see it's 135 degrees, and here this one is 120 degrees. Now let's come back to the arc length. Okay, remember this in unit circle. This, if it was 1, so this was like theta, and here theta. So the numerical values of the length and the angle was same. But here, if we have r units, so it's not 1, we generalize it to r. So what's the relation between the arc length here? And what is, if this is s units, what's the relation between the theta in radians, r, and s? So here is the formula. The arc length is equal to theta times r, and theta is always in radians. So if you take r equal to 1, we get back to the radian calculation again. So we say theta is equal to the arc length. Here if we have this, we will get back to here. Anyway, now we will assume, in our questions, the radian might be 1, or it might be different, or more than 1, less than 1. So here also, if this is 2 pi here, what do you get the arc length? Like it will be 2 pi. If theta is 2 pi, then the perimeter, the muhit here, will be, okay, s equal to 2 pi times r. And this gives you the circumference or perimeter or muhit of the circle. So we have the circle formula, the length of the circumference formula. Let's look at this example. says find the length of the arc corresponding to the central angle of 1.2 radians and on a circle with radius 2 centimeters. So it says the length of the arc. Okay, there's an arc and corresponding to a central angle. So we have an arc corresponding to a central angle. So this is the central angle here, and this is the arc corresponding to that central angle, and we don't know this one. We will find the length of the arc, and it corresponds to the central angle of measure 1.2 radian, and the circle has the radius 2 centimeters, so radius will be 2 centimeters. Now how can we calculate the length of this arc? Arc length is equal to, we know the formula, arc length is equal to theta, so the angle, central angle times the radius. So central angle is in radian times 2 centimeters, so you got 2.4 centimeters. So you can use this degree, this angle directly in the formula because it's in radians. So the good thing is in radians. Now, otherwise you have to, if it is given in degrees, you have to change it to radian to use it. Use the formula. Now let's look at this one. Find the length of the arc corresponding to the central angle of 120 degrees on a circle with radius 3 inches. So we want to find the arc length and the corresponding circle, the central angle is. It's 120 degrees. Okay, maybe it's a little, like that maybe, because it's more than 90 degrees. So it's 120 degrees. Now the radius is 3 inches. Now it's asking the arc length. What is arc length? The arc length formula is, it's equal to central angle times the radius. But here, this has to be in radians. So, okay, this is not in radians. So theta is 120 degrees. So how can you write it in radian? So you have to find this one. Okay, I can do this 180 degree is pi radian. And now 120 degree is how many radians? So I can do this, product. It's 120 pi is equal to 180 divided by, what's this? X. So you divide both sides with 180. So we end up with 2 pi over 3. So we found this theta is, the central angle here is 120 degrees is equal to 2 pi over 3 radians. Now we can use it in the formula. This will be then 2 pi over 3 times the radian. The radius, sorry, this is 3 inches. So then after cancellation, you will get 2 pi inches. So it's approximately 6 inches. Let's look at this example. Find the degree measure of the central angle that is subtended by an arc whose length is 3 centimeters in a circle with radius 2 centimeters. So let's try to understand it. Find the degree measure of the central angle. Okay, now it seems there's a central angle here, so we can do it this way. That is subtended by an arc, so it sees an arc here. This is the central angle. And there's the arc. Now the arc length is 3 centimeters, so this is given, and the radius is given 2 centimeters. circle. Now, what is the central angle then? What is the central angle? So it's better we say theta is equal to central angle, and then we can calculate it. Now we can use the formula. The formula here, the relation between central angle, arc, and the radius is S, the arc is equal to theta times R. So the arc is 3 centimeters. Theta, we don't know it yet, this is central angle, and the R is 2 centimeters. So then you can calculate it's 3/2. But theta is always, if you want to use this formula, if you're using it, it's always in radians. Okay, but it's asking the degree measure, so you have to calculate what is this in degrees. So you have to calculate it. So how can you calculate this one? You can directly, you can use a direct proportion here. I mean, as I did earlier, that you can say pi radian is equal to 180 degrees. And what can we say about 3/2 radian? So you can say x, and then you can multiply pi times x equal to 180 times 3/2, and this will give you 270 degrees. Pi, you divide pi, so you both sides you divide, and you get 270 divided by pi. So this will be the degree measure of the angle here. So theta will be 270 degrees over pi. So it's about 90 degrees if you take pi to be like around 3. But this is the exact solution here. Let's look at this try and check exercise. Find the length of the arc corresponding to the central angle pi/3 radian on a circle with radius 1 inch. So again, it's talking about an arc. So arc corresponding to the central angle. Central angle is pi/3 radians, and it's on a circle with radius 1 inch. So the question is, what is the arc length? So the arc length is equal to, again, theta times r, which is central angle. This is central angle, and this is the radius, and this is in radians. Okay, this is radius, this is radians. Okay, now this is theta is pi/3 times 1 inch. So we can directly say it's pi/3 inches. So the arc length, as we said earlier, I mean, this is, if the radius is 1 unit, then the arc length is equal to the measure of the angle, numerically. So it's pi/3 radian, so pi/3 units, or what is the unit? This is inches, so you say pi/3 inches. Find the length of the arc corresponding to the central angle of 200 degrees on a circle with radius 1 inch. So we have, okay, it says asking the length of the arc corresponding to a central angle of 200 degrees. Okay, it cannot be 200 degrees. It has to be something like this, maybe, because it will be bigger than straight angle. So we can say this is 200 degrees now. So this is 1 inch. What can you say about the arc length? So again, S is equal to theta times R. S theta, okay, theta is 200 degrees, but you cannot use it this way. You cannot use this, so you have to change it to radians. So you can divide by 180, then multiply with pi. I'm using this You can do, as I said earlier, you can make the proportion and you can do it, but here I will go quick, and this will be something like 10 pi over 9, I guess. Yes. So then it's in radians, so you can put it here, 10 pi over 9 times 1 inches, so you got 10 pi over 9 inches. So the arc length will be 10 pi over 9 inches. Now find the degree measure of the central angle. The central angle that is subtended by an arc. So there's an angle, it's subtended by an arc. The arc whose length is pi over 3 centimeters. Arc length is pi over 3 centimeters. In a circle with radius 2. Now the question here is theta. What is theta? The central angle, the degree measure. So the relation is now S is equal to theta times R. S is pi over 3 times, and pi over 3 centimeters is equal to theta. Theta, we don't know theta yet. R is 2 centimeters. Yes, you can cancel out centimeters. And then theta will be equal to pi over 3 over 2. Right? You divide both sides with 2. And then you end up with theta is equal to pi over 6 radians. So here again, it comes to changing pi over 6 radian to degree. But I will go quick, and I mean, you can do this radian degree, you can do this, calculation here, but I don't want to do it. In the video, I did a lot. So this pi radian means you can go quick. Pi radian means 180 degrees divided by 6. So theta should be equal to 30 degrees. Now, if the vertex of an angle is located at the origin and its initial side is along the positive x-axis, we say the angle is in standard position. Okay, now, well, we have seen the angles like that. We said this is an angle and this is an angle. This is an angle like that. Well, now we want to put these angles to here, to the original. I mean, to the Cartesian coordinate system. When you put them, you will put them in the Cartesian coordinate system by doing this. First, you will put their initial side and then terminal side. And if an angle is given in the Cartesian system this way, the vertex is at the origin and the initial side is at the x-axis, at the positive x-axis, then we say theta is in standard position. Now, if your theta is big, like 200 degrees, so how do you put it in place? How do you put it in standard position? You put theta, 90, 180, and 200. So this will be your angle here. Now it says, place the angle whose measure is 300 degrees in standard position. Now 300 degrees is, okay, you can first, so since it says standard position, you will place the initial leg or initial side on the positive x-axis and you put the vertex here, and then you go for 300 degrees. So you can go with the rotation here, 90 degrees, 180, 270, and then here 30 more, so it will be 300 degrees. So you got 30 more, so in total it will be 300 degrees. and this will be the initial, the terminal side. So this is how you do it in standard position. Now, the other question here is place the angle whose measure is 2 pi over 3 radian in standard position. Okay, it will be hard to do the things with the radian, so it's better we change them to degrees. So it's better we do 2 pi over 3 radian is equal to how many degrees is it? So, I mean, pi radian is, to me, it's 180 degrees, so I can say multiply 2 times 180 degrees, so it will be 120 degrees. So 120 degrees is, okay, again, vertex, origin, and then the initial side. In 120 degrees, it's in the second quadrant. So then it's 120 degrees is this one. This is 120 degrees in standard position. Yeah, you can also say 2 pi over 3 radian. And that's it. Thanks.